I'm going to make a habit of going through the homework and the tried outs with you guys, just as a class. I don't know if that's helpful at all, but the other problem is this class is a little unbalanced as far as I have 4 hours of lecture time this week to teach you about if statements, and it's kind of hard to stretch 4 hours. So yeah, I'm hoping today we can go through the homework assignment, get through the lecture, and then not next week, but on Wednesday, and honestly like go over our tried out assignment, and then maybe just like work on the homework or whatever. Just for the next few weeks, it's kind of hard to. I don't know. There's a lack of material, but then after midterms, I have the opposite problem where it's like too much. So we'll get through it. Okay. So this assignment, we're to build a simple calculator. So the idea of this assignment was to get you used to the IOManip library as well as the CMath library. The IOManip is what gives you the set width, the set precision, and then the CMath is what gives you like the square root function, the power function. And so we just want to get you used to some of those functions, and then also just in general, getting used to getting your toes wet with C++. Now, there are some things that might be confusing you guys because you probably still don't know really what that is. You got functions going on. You got this weird thing down here, and you're like, what in the world am I supposed to do with this? So I know there's a lot of stuff that can look confusing to you. As we go through the semester, like little by little, it'll be unveiled to you what these things are. Like we're going to get into header files. We're going to get into functions. We're going to get into a lot of that stuff. But for right now, I understand that it can seem a little daunting. So just keep it simple and just put your code. When you have a to-do, just put your code right underneath it. When you have the next to-do, put your code right underneath it. Don't erase anything that I have. And here's why. Let me show you my completed version, so you guys can kind of see what's happening. So your guys, if you did your homework, you should look something like this. You have your to-dos, and then you have your stuff underneath it. This is what we call a function, which went over the first and second week. Each function, what I'm doing is I'm calling that function down in main. Remember I said main is the driver? What I'm doing is I'm calling each function. And the code in that function is what you guys are doing. And what's happening is, if I open up this test file, this thing is a program that I made to call your functions and fill it with different parameters, and I'm just testing different scenarios. So this first function is called check test, and basically I give it a test number, and then I look at how many tests you got correct, and then what the answer should be versus what it is. So what is the output your function gave me versus what is the output it's supposed to be. And so when you come down here, notice that I'm calling your function here, and then I'm looking at the result, and what's captured is what your function was showing. What it's supposed to be is what I hard-coded as based on what I'm feeding it. So what you guys can do is, let's say you work on your program, and what you can do is you can hit build, and then you can hit play. The first time you hit play, you might see like these two different options. For the Visual Studio guys, it's going to be a little bit easier for you because on your little play button, there's a drop down and you can pick which executable you want to run. For VS Code, it's a little bit more terminal based. But so the simple calculator should be your guys' assignment, right? I click on this and it should ask you different things. I don't know. Okay. So it ran my program, right? Well, now let's say you're like, okay, cool, it gives me numbers. I want to know if they're right, though. What you can do, like I said, Visual Studio guys, you can just choose the other executable. But for you guys, notice that the executables are in this build folder. So simple calculator, this is the executable. This would be like what you'd run on your desktop to run the program. And this is the executable for the test program. So you need to look and see where it's at. So it's just in build. Notice that I'm already in build. Because I'm already in build, I just hit I hit this dot here, then I hit /, and then I just put the name of the executable, which is simple calculator. And I don't put .cpp because I'm not running that. I'm running the executable. If you guys were up a directory, like you weren't in build, you would just do build / right, simple calculator. Make sense so far? I hit play on this. It ran my program. Notice that it says test 1 passed, test 2 passed, test 3, and it tells you how many you passed. If any of these were wrong, it's going to say, hey, test 1 failed. The output you provided was whatever. The output should have been whatever. So you can kind of see. Another way you can do this, which is really cool, let's say you only have like problem 1 done. So if you run it, it's going to fail because you only have one part of the assignment done. If you go over to this this little test and you expand it, if I hit the play button on this, it's going to run through all the tests. But if you can go one by one and see if those individual tests passed. So in my CMake, I have a test. For every test that you guys see in my program, I have it defined here so you can run the tests individually. And you would see a red X. So from my end of things, please hold. Where's my internet? My goodness. So from my end of things, when I get your guys' assignments, I'll show you an example of good and bad. So the bad example would be this. So when I pull up your assignment, I get something like this, right? And I go in and I can actually look at your code from here, but you see this X here? That means it failed one or all of the tests. So when I hit actions, I can see each commit that you guys did and if it passed. And then I can go into it and I can look. And yeah, it just straight up failed. And the reason why it failed is because this is my starting code for you guys. But you notice if I see any of this, I know right away that you guys didn't pass something. And if you guys didn't pass something, I go into it and I look and I try to see why it failed so I can give you some helpful feedback. But compare that to something like this. See the green check? That means it passed everything. So I go here, I click into it. Why isn't it showing me the stuff? Normally it tells me. Anyway, yeah, and normally I can see exactly what your outputs were and things like that. So that's a little bit of background on my process. So hopefully that gives you guys a little bit of clarity. Any questions on that?
Can you go over what you put in on the output, simple calculator?
Oh yeah, okay. So what I do is I pull up the terminal. So the terminal is just like what you can type in, right? And I need to run the executable. And so I need to find where the executable is, and it's going to be in the build. So what you do is you look at where you're already at. This is the directory you're already at. Since this says build, I'm already in the build folder. So you put a dot. This means with the path link, grab everything before it. So it's dot and then a /, and then the name of the executable, which in this case is simple calculator test. Right? Or if I do it like this, then it'll run, then it'll be mad at me. Why are you mad at me? Oh, because I spelled calculator wrong. Anyway, does that make sense? Okay. So what I'm gonna do is we're gonna walk through the assignment. You guys are gonna walk me through the assignment. How about that? So the first to do, create a variable type double named R. So how do we declare a variable? Double. Now what value is R right now? Yeah, some random spot in the stack is what it is. We didn't give it a value. Okay. So create a constant double. How do I make a constant double?
Constants.
Named pi. And what does constant do?
It keeps it changing.
2, 6, 5. So later, can I put like pi equals 7? No. Keeps it constant. Good. All right. That should be easy enough. Oh, semicolon. Okay. Prompt the user to enter the radius. So something like this, right? Enter the radius. And what should I do here to end the line? What are the two ways? Well, so semicolon,
And no.
yeah. So end L is one way. The other way is you can do this /n. Either way, that just ends the line, so it's going to give you an output underneath it. All right? You don't have to, but that's just, yeah. Okay, so how do I prompt the user to enter something then? Sin, like that, right?
And then the arrow, yeah, that way.
Yeah.
And then more.
So we have the insertion operators versus the extraction operators. If you ever were given a pop quiz on it. Okay. So now they're going to say enter the radius, and then you would put the value, and it would assign that value to r, right? Okay, so now calculate the area. So how do you find the area of a circle?
It's radius squared times pi.
Okay. So,
Pi times radius squared.
okay, so when we do that, where are we going to store that value, that area?
Squared in area. So I do double area.
Make sense? Everyone? Okay, and then how can I do this in C++ language? How can I write that area that you just described, that formula?
Equals pi times pow. That's the C math. And then r, comma, 2.
Okay, can you explain that POW function? What are the parameters of it?
So then everything in order. So it just means power 2. So you're taking r, whatever the input is, and you're timesing that
Yeah,
by itself.
just raising it to the second power. Could I do something like this in theory? This would be like r to the 10th power.
That'd be a big number.
That would be a very big number. So that's the POW function. Most of you guys, which is totally fine, most of you guys did this. You did pi times r. That's totally good. But what if you did want to do it to the 10th power? You'd be doing a lot there. So that POW function is really, really useful. Okay.
I guess I wasted code in here because I did double area and then semicolon, and then down below I did area equals pi times power. So I said,
Yeah.
I guess I didn't need
Yeah, it's kind of a double-edged sword when you do things like that. On the one hand, if you do everything on one line, it can make things a little bit more condensed. But on the other hand, if you need a debug, it might be good to break out every piece like that, because then you can track individual variables and see why is this acting funky. So keep that in mind. It's a tightrope walk when you guys are figuring out, should I break this out into a variable or should I not? It does not hurt to break things out like the way you did it, because then it's a lot easier to track. It just makes things maybe a little harder to read. So that's judgment calls, but totally fine what you did. There's not like a computational, like it's not more inefficient the way you did it. That's totally fine. Okay, display the area, and then we have to use the set precision. So how are we going to do that? C out, right? So okay, we know this, right? If we want to display the area, it's that easy, right? But what about the set precision? How do we do that? Okay, before area. And we want it to 10 digits.
Put 10 parentheses.
Yeah, put 10 here. So what's going to happen if I run this? Yeah, you guys are so smart. And if I do fixed here, then it's going to be just 10 digits to the right of the decimal, right? that make sense? Okay. So we've done problem 1, right? Now to kind of explain to you what's happening in the background, the reason why it was important for you guys to call your variable area is because look what I'm returning. Remember, return means you're taking a value and you're pumping it out of a function. So the reason why I return area is so in my test file, I can grab that value you guys calculated. So that's why, like, if you did, for whatever reason, you want to call it like area 2 or whatever, or area 57, there you go. So that would get you the right answer, but then you'd still fail the test case. So that's why, like, look at what I've already named variables. And so you were like, all right, he's returning area, so I should probably call it area. Just keep an eye out for things like that, right? Okay, calculator 2. Create variables for each, numerator, denominator, and slash to represent the slash. So I'm already printing out the first fraction. Prompt the user to enter the first fraction. So I could probably do something like, how do we do this, guys? Should probably declare variables first, right? So A, B, C, D, and then this part's really important. Some of you guys skip this part, but that slash is really important. We'll explain why. So, so if I'm expecting the user, because right here we're telling the user how we want them to do it. We want them to write it A/B. So how can I prompt the user to do A/B? Like that?
Yeah.
Okay.
That reads it as a string and not as an integer. It's not going to start dividing the graph.
Very good. Yep. Another thing you can do is you can actually just put your variable in there. So either
/1 and /2 later on.
yeah, so either way, it's just going to be like a character feed, and it's going to populate that second character. So the first thing they put is going to be stored in A. The second thing they're going to put is going to be stored in slash, right? And then B, like that. And then the third thing they're going to do is going to be stored in B. Okay, so then the second fraction, it would be it would be C slash, not that, D. Does that make sense? Okay. Enter the second. So then add the fractions by using the formula. So this part can get a little trippy here. But basically, if you look at that formula, there is something happening on the numerator and something happening on the denominator. So what I did was I created a variable to represent that final numerator, and then I created a variable to represent that that final denominator, right? So let's do the denominator first, because that one should be easy. You guys remember the formula for that, calculating the denominator? B times C. Or, no, B times D. Yeah, thank you. And then the numerator, what was that?
A times D plus B times C.
B times C. Now, order of operations. Another reason why we do this. Does this work?
No.
Why not?
I'm going to put A, B, parentheses, and B, and C, parentheses. That way you multiply first, then add together.
Does it work though with order of operations?
Yeah, I would say that's how it is in mine. It works.
Yeah,
Because
so
it's just reading it, right? It's reading it left to right, so it has to follow that.
yeah, so what is it? The ped mass or whatever? All right, we're gonna write this on the board. Parentheses, exponents, division, multiplication, addition, subtraction. You guys seen this before? So this is the order of operations. This is just standard in math, and this is also applies to C++. So the first thing that's going to be calculated are things in parentheses. That's why what you suggested is totally good. You put in parentheses, we know we're being safe here. The next thing it's going to look at is exponents. Division and multiplication are synonymous, so it's actually just whatever comes first. And then addition and subtraction are synonymous, so whatever comes first. So in ours, it was A times C. No, A times D. A times D plus B times C. So according to these rules up here, does multiplication happen before addition? Yes. So it's going to multiply, get you your number, and then it's going to multiply, get you your number, and then it's going to add that. If you were to put in parentheses, it's going to multiply, get you your number, multiply, get your number, and then add. So it's the same thing in this case.
I wasn't sure if it was going to be like a calculator where it would just
Yeah, it just goes left to right.
go left.
Nope. C++ follows order of operations.
That's nice.
So
That would be nice. That would be
for those watching the video, you can skip ahead because I didn't show my screen on that. Okay, so yeah, either way works, right? So then we have this, B times D, and then this whole return thing, right? You don't need to worry about that, whatever, doesn't matter. But I do want you guys to display it. So how do we display final num? And then how do we show the slash?
In the quotes with slip.
Final num. Single quotes are when you're dealing with characters. Double quotes are when you're dealing with strings. Just FYI. If you define this as a character, you should use the single quotes. All right. 2 out of 3 done. This one was the tricky one. Yeah, what's up?
Make an observation.
Yeah, what's up?
It'll help you look in the program if you assign your variables to known values.
You assign them to like null.
Well, so like if you go up to where you get your fractions, A is equal to 0, you give them something because otherwise you're getting whatever garbage is in the memory address. But it's all until you find the reason you're saying.
Yeah, so what Michael's saying is, let's say you're debugging and you're getting A is equal to some like hexadecimal garbage, and you're like, what in the world is happening here? That's because when you don't assign a value, it just grabs the memory address, just garbage, like Michael's saying. So it's good practice to give it a value, because then if it says A equals 0, you can be like, oh, for whatever reason, after line 35, it didn't update the variable like I expected it to. It gave it its initial value. So it's a little bit easier to debug, and it's a little bit better practice. That is a good observation. Thank you. Yeah, experience. That's what 20 years experience gives you, right? Thank you. That was good. So, quadratic formula. Does that look familiar, guys? So this is the quadratic formula. This is how you find x-intercepts. You know those parabolas? You want to see all the points where the line passes x, right? So this is the formula. So negative b plus or minus the square root of b squared minus 4ac divided by 2a. And that's what we want to figure out next. Notice with order of operations, you guys are going to want to figure out this b squared. You want to do the minus 4ac, you want to do the square root. You want to figure out this whole numerator part and divide it by the denominator, right? So keep that in mind. And then also this plus or minus means there's going to be 2 answers, because we have to do the plus version and then we have to do the minus version, okay? So here, yeah. what did were these? Yeah, I made these integers. So, per Michael's suggestion. So far, so good? Okay, this part. So, there's a lot of different ways we can do this. Someone want to give a stab at it? Okay.
So if you could go back to like the PDF,
Yeah.
it like just helps. Like it's kind of how my brain works. I kind of like broke it down, I guess.
Okay.
So like that minus b is going to be the first of every, like that's where you're starting.
Uh-huh.
So I started everyone in like this big parenthesis and just did minus b. Like for both of them.
Did you like put it in here?
Yeah. So I did like
Okay,
minus
my-
b.
yeah.
And then I did that in the negative solution too. So I did
Okay.
minus b because that's going to be the same. And then I did the plus right after.
On the positive,
one.
and then the
Well,
minus.
inside of the parentheses, sorry. Because there's going to be two parentheses.
Okay.
A plus and then a minus for the negative solution. And then square root, because you're square rooting that entire next segment. So I kind of put more parentheses. So square root and then parentheses again.
Like that.
Yeah. And then I did, since it's b squared, it's b times b inside of there. And then minus 4. And then times a times c. And then I go out of both parentheses.
Okay.
And then divide, and then parentheses again, and then 2a. And I just did that. Basically same thing for both.
Actually, just
Because the only thing you change is just the plus or minus.
does that make sense? Okay, so when we look at this, these parentheses mean that this is going to be calculated first, right? Negative b, square root. Square root's going to be calculated before. Since it's multiplication, we're going left to right, so it's going to do b times b, then it's going to do 4 times a times c, and subtract those. And then it's going to add that to negative b, and once all that's done, then it's going to do 2 times a, and then it's going to divide. And that's about the order we want things, right? To your own point about breaking things down, I've seen a lot of you guys also, instead of doing it in one line here, because I can get a little bendy brain here. I can't remember the math terms right now. Discriminant, is discriminant the top part? Discriminant, I can't spell it, but that's okay. And then basically what you would do is you do that part, right? Or you could even go the numerator denominator approach or whatever and kind of break it down. But either way, it's the way to do it, right? Okay, display the results. Was there... I can't remember exactly if I told you guys to display it in a particular way, but this is how I have it in mine. All right, and then notice there's no more red. That's good. So we'll save it. We'll compile. Exit code 0 means that it compiled. If I run it, let's run it here. We can see it did its thing. NaN means not a number. Not everything has a real solution. So, but if I do this, it passed all 3 tests. So that's how you guys know you did it all right. It passed all 3 tests. Go here, put in your messages, commit, sync changes, and you're solid. Any questions?